Hello everybody, I'm Corbin with No BS Repairs, and today I'd like to show you a video of how I repair a Nintendo Switch with a broken USB-C port. So first things first is we have to take it apart, and the customer came in saying it was a broken USB-C port, and I confirmed with looking at it under the microscope, and all the pins are usually pretty messed up. One day I may get a microscope camera to show you. At the moment I don't have any such thing. So first things first, we have to take this apart and mind my messy workspace. So you want to get a screw container, keep track of your screws, or if you have a magnetic mat that works as well. So the back 4 screws, use this silly tri-wing connector. And then Phillips, you want the middle screw on the rail. And on the other side. And then one on the top. And what I find, the screws on the top and bottom, the screw holes on the plastic casing often break from the customer's use because it's kind of cheap plastic, so they might have troubles coming out. If so, just loosen them and then they'll pop out once you take the casing off. And then 2 on the bottom on either side of the USB-C port. And then you'll have one underneath the kickstand, and that's right under the micro SD card slot. So that came out, and then the top screw just kind of fell off because these casings are a bit cheap and the plastic breaks all the time. So then you take off the metal backplate and your micro SD card reader, which then will just pop off as it uses a little Lego connector. And you have 1, 2, 3, 4, 5, 6, 7 metal backplate screws. And this metal backplate is used for cooling a little bit and probably EMF protection. Although I have a feeling the cooling effect is negligible, as I've seen people online who do mods where they just remove the back plate. And then, yeah, it has this funky goop there. So then we disconnect the battery, first and foremost. And with a pair of tweezers, I'm going to start disconnecting all of the little ribbon cables. Just one at a time, so we're being careful. The speaker connector, it has this little notch in it, so I just use the tip of the screwdriver, and that helps pop those out. Because they're tricky, and you don't want to be pulling from those cables as they're very thin and fragile. So, ribbon cables on the side, like so and so. Wi-Fi antenna connector, Wi-Fi antenna. And then I'll start undoing some screws from the motherboard. You want to keep track kind of mentally, or you might want to take pictures if you're doing it yourself, as some of the screws are different sized. They're black, and they go directly, they touch the motherboard directly. The ones that don't touch the motherboard directly, like what connect to the USB-C port and the heatsink here, are silver, and they're the exact same screws as what the metal backplate uses. So we'll go through that and that. Like so. So now I take off the heatsink. I try to preserve this, if you can see, this foam here. It rips pretty often, and I've found no way around that. So you just kind of carefully try and rip it up. The most important thing though is you don't want to bend this heatsink. because that can damage it. Oh, and I got it off in one piece. That's pretty rare. All that foam. But yeah, you don't want to bend the heatsink, as that can definitely cause heating issues, as that heatsink has kind of a spongy copper in it with a little bit of liquid, and that helps transport heat. So next you want to take off the game cartridge reader and the headphone jack, which is all one component. So it connects to the motherboard with this Lego connector. And also a ribbon connector to the touchscreen, which you want to be careful with. It's not hard to, or it's not easy to rip the actual ribbon connector, but I find it's very easy to damage the pins inside the connector there. And then same goes for underneath that. You have the display connector, or LCD. And that connector is also very fragile, and the pins can be bent very easily. So the last few ribbon connectors are the fan and the power button and volume buttons. So we can pop those off. You can take out the fan now. I don't always take out the fan, but it's a good idea, as it kind of blocks the motherboard from going in and out. Undo the rest of the screws from the motherboard, and the motherboard will just pop out. So now that it's out, we can put the body to the side, and we have just the motherboard. So now time to remove the USB-C port. So I'll go grab a brand new one. I don't remember where I bought these from, somewhere in China. They just come in like a reel like this, and then you just get one like that. Like so. Removing the old one is pretty easy. You just want to be careful not to put too much heat for too long, as it can mess up the RAM, because it's pretty close, but you have the heat shield covering it. And then there's also a plastic connector that connects to the left Joy-Con rail. So using a hot air station, taking it off, you can use 350 to 400. But then putting a new one on, you want to use 350, as you don't want to melt the new connector, as it has plastic inside. Sorry, it's a little bit... I'll see if I can fix the lighting there for you. And I just use 400 to take it off, because I don't care about the old plastic melting at all, and it just gets it off quicker. So now we have the old one off. Here's where things get a little bit tricky. Sorry, it's so hard to see here. So on the, let's see if I can get this to focus. On the old one, you have these 4 holes here that are kind of the structural holes. There, and there, and there. So those, it's hard to get the old solder out of. So what I find is easiest is I have this PCB holder that the Switch motherboard goes into. Like so. That'll hold that snug. And then I'll use the hot air station at 350-ish. And I have a solder sucker, like so. You can buy these on Amazon for pretty cheap. So I use the hot air station from beneath. And you can heat up those 4 connectors. And this sometimes will take a little while to get it hot enough all the way through. And then you can suck the old solder away. Yeah, and this wasn't hot enough yet. We'll give this a minute. There we go. Got one done. Got two done. Got that one done. And got that done. So now all those holes are empty, ready for the new connector. And I'll have a quick look at it under the microscope to make sure I didn't knock any components off, because that solder sucker isn't the most precise thing in the world. It all looks good. So now with a soldering iron, I will prepare the little tiny pads, of which there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 24 connectors that the USB-C has. And so we'll prepare those by putting a little bit of flux. And then with the soldering iron, we'll run over it with some nice new solder and make sure they're prepared for the new one to go on. And this will just take a second. I just want to make sure they're kind of evenly wet with solder and kind of the same height. Just need a little more flux. Ugh. I really do need a new soldering iron tip. This one is getting really crusty, but that's okay. Yeah, so that's good. And again, I'll put a little more flux on in preparation for putting on the new connector. The new connector I want to look at under the microscope to make sure all the pins are aligned, as I've gotten some that are kind of screwy, but this looks good. Yeah, I have no issue with that. And then putting the new one on. So this is where it's a little bit tricky, because you want to have, so on my mat, as you see, there's these grooves. So I have the motherboard now resting over the groove so that the USB-C connector is sitting above that, so it has a bit of space for it to fall, because I want to press down and make sure those pins are aligned. And so it needs that little bit of space. And so now, with my hot air station, I actually just set it to 340 to be safe. Now we want to quickly get these pins melted on. without melting any plastic on the new connector. And under the microscope I can see they're already melting, so I'll just do this for another maybe like 10-15 seconds, and I'm pressing down with my tweezers on this to make sure these pins are all nicely aligned and getting squashed into that solder that I prepped it with. And that's good. Yeah, so now I'm just holding it down after I took off the hot air station for a few seconds to make sure everything dried well, and that's good. So now with the soldering iron and a little more flux, we're going to put more solder on those support pins, like the ones that we use the solder sucker on. As we don't want to plug anything into this until those are well supported. Because if you plug something in, if you've only done these little tiny pins, it might rip, and that'll destroy the motherboard and you'll have a sad day. So now under the microscope with my soldering iron again, we will make sure these support pins or these support posts are well soldered. And flux makes all the difference. It's the magic that allows you to do this with no problemo. And it helps if you do this right after you've put the pins on, because the board will still be warm, and that'll help the solder flow a little bit better as well. Now I flip it on the other side, make sure it's gone all the way through, which I would say it has, and just touch it up a little on these tiny little holes next to the back pins, which are extra support. Make sure those are soldered, and just give it a little more. With this, as long as you're not leaving a big lump, the more the merrier. Because you do not want this thing moving when it's getting plugged in and out and in and out and in and out all day. And that looks good. I'll show you here. If you can kind of see. Oh. Sorry, it's having trouble focusing, but there we go. Sorry, I just had a cut there by accident. But yeah, that's all connected properly. So now I'll test something before I put it all back together. I have a USB-C connector, and that's plugged into a proper USB-C power delivery charger. And then I have this USB-C volt and amp meter, and this will just make sure it's charging correctly, as sometimes when your pins are bent you have to replace the M92 T36 chip, but in this case I see we're getting can you focus? We're getting 14.6 volts, which is close enough to 15, so that means the M92 T36 chip is working just fine, and this board is getting the power it needs. So next, we will put it back. Oh yeah, we want to wipe it down a bit with a Q-tip and alcohol to get rid of that flux and some of the other junk that was left there, including the little water damage tag. There's a little water damage sticker on here. that gets burnt because it's right next to the work we've done. But that's okay. Now Nintendo will never know if it's water damaged. Oh well. So I'm using a Q-tip and a bit of isopropyl alcohol to make sure it's all clean. Oh, so, okay. Yeah, as I'm cleaning it, I just noticed something bad. There's a resistor, or I think it's a filter, a double filter actually, that goes to the PI3 USB chip, and it's burnt to all heck. And that's something that can happen with these cases as well, when the pins get bent because they short things out. So I'll have to replace this filter, and I'll have to see as well if we have to replace the PI3 USB chip. I'll be able to tell more accurately once I've replaced the filter, and then I'll try powering it on and seeing if we get a display out on the inner display and if we get display out on HDMI through the dock. So the pins were a bit bent here, or the pins were a bit damaged from this old bad filter, but that should be okay. I'll be able to save this. I don't see often if the PI3 USB chip is dead, I often see there's a hole in it, like a little burnt hole, but in this case I don't see that. So I'm hoping the filter took the brunt of the force here. But we will see once I replace the filter, and I will do that from a donor board. So the one that I'm swapping from the donor board, this is the donor board, and it's a dead motherboard from something else, probably like dead CPU. So it's hard to see, but the filters are those little tiny parts above the USB-C connector there. And they go to the PI3 USB chip, which is responsible for the USB 3 control. Well, I hope that hasn't been out of focus the whole time. I do apologize. So I will steal the filter from this other board. Use the hot air station for that. And then we will put it on the new one. Oh, and interestingly, the new one actually uses smaller, this board I just got, this one, that filter won't work. As this donor board looks like it's an older revision, so it's using larger filters. Aha! So I will dig through my donor boards and see if I can find one with the newer filters. In this case, it looks like all my donor boards are the older revision with the smaller USB filter, those filters. So what we'll have to do in this case is run little wires, and hopefully that works. The filters are for filtering noise or junk on that line, but I hope it's something that's very minuscule and won't cause any issue. Because a lot of the time when they're building these, it requires they have very high standards for noise filtering. So I'm using some, what the heck is this called? It's high gauge wire. It's 40 gauge. They call it, I guess it's called magnet wire or something like that, but it's used for doing tiny little micro soldering work like this. I need a little more flux here. Do this properly. This is why the microscope helps. Okay, so we got one done. Oops. So in these cases, when I do USB-C repair, I charge a flat rate of $150. And that includes if I have to do things like this, where we're doing extra repairs, because when the USB-C port goes, it's not always just the USB-C port. Sometimes it's the M92 as well, and sometimes it's the PI3 USB and supporting electronics, such as in this case the filter. I wish I had the microscope camera to show everybody here. It'll be very hard to show this after the fact, but we'll see. So I just ran these two little wires. I have a feeling it'll work. Filters aren't always the most necessary in the world. It's like for compliance quite often. So they meet regulatory standards and aren't consuming too much noise or very, very specific things that a proper scientist and electronics engineer could tell you. Yeah. Yeah, so that's good. So I'll test this to make sure it turns on and works on HDMI and works on the inner display, all of that fun stuff. And if so, then we're good. If not, then I will try replacing the PI3 USB chip, although I don't know if I have any at the moment in stock, because they are tricky to get. I need to order more. So I'm hoping that this will fix it. I'm just going to wipe this surface off here. This work surface is all covered in flux and some thermal paste from the CPU. So we wipe all this off. Bada boom, bada bing. I just use some alcohol spray and paper towel. fun. Okay. So if this works, then I will cover those little wires I just did in some UV coating. That's this, and that'll protect it in the future, since they're like just these random little wires now sticking out of the board. And it's good for warranty. So when I'm testing it, I just plug in the bare minimum. And the bare minimum is your power button and volume buttons, and the backlight and display, and the battery, of course. Once you have those in, you're able to test if it turns on, things show up on the screen. In this case, though, I bet the battery will be dead, at the very least. So I might have to let it charge for a while, if it works. So battery, backlight, display, and power button. And now we'll see if it powers on. I'm not getting anything on the screen, so I will plug it in with the USB-C connector again, and we'll see if that does anything. Or I'll plug it into USB-C, see if we get a battery light. And no battery lights. And the voltage to me doesn't even look like, so it's drawing 15 volts and 0.2 amps. And that doesn't show me that it is charging the battery either. So we might have more things going on. The old pins were pretty badly tangled, so there can be more things going on for sure. Let me look at the battery charge chip. Looks okay. Yeah, so more than likely the USB, the PI3 USB chip is toast. Tosto. Yeah, that's what I'm going to guess here. And do I have another PI3 USB chip? I do, from a donor board. I do indeed. So, after this video I am going to order some more, because that's getting bad. When you're doing Switch motherboard repair, you want to have the PI3 USBs in stock, and you want M92 T36s in stock, and you want some BQ2419-3s, which are the battery control and charge chip. Okay, so I'll be taking off this old PI3 USB. So that's the old one. Flip it upside down so it's a dead bug. Dead bug chip. And then the new one, well, hopefully it'll be good, from this donor board. Like so. And so now I'll prep the motherboard we're repairing. I'll prep the pins for where the PI3 USB chip goes with some flux. And we'll run our stuff over our flux or our solder. Just prep those pads with some nice fresh solder. Actually, I'll need to use some solder wick here first. Because I just got some on the ground pad there, or the center pad. There, like so. And I would say that's prepped. So now we can put the new one on. And if you ever want to know how to know the orientation of where to put the chip, there's a dot on the chip, and that shows where pin 1 is. On the Switch motherboard, there's a copper arrow pointing roughly in the location of where pin 1 is. So in this case, it's in the top right corner, from if the USB-C is on the bottom. That's like how your orientation is. Okay, so the new one is on, and then again I'll put some more flux on, because even after I've hot air stationed it on, I want to go around with my soldering iron to make sure those pins are getting good contact to the chip best I can. I'll just run over each pin with my soldering iron. Some of them are tricky because there's some capacitors and resistors around here. That's okay, just be careful and make sure you have a good small soldering iron. Like the one I have is the Weller WD1, I think, the iron, and then I don't know what, or yeah, the station, and then I don't know what the heck iron I have for it. It's the one that came with it. Alright, so that's good now. New PI3 USB soldered on, and my replacement filter wires are still there. We'll let that cool off for a minute. And I do apologize about this crazy mess of a workstation. An interesting thing is this is a standing workstation. I had it custom built from a carpenter client of mine, and it's quite excellent as it lets me stand up and work instead of sitting all day. Most people who do this kind of sit all day, and it's maybe not good for your posture, or I don't know, but I like standing up. There. Make sure you're centered there. Okay. So this should be pretty cooled off now. And again, we'll test and see if we have any life from this poor Switch motherboard. If this doesn't work, it's either going to be because those filters are really needed, or this PI3 USB chip is dead, or the BQ chip is dead, perhaps. I don't think M92 T36 is dead, though. I don't think so. It's unlikely. Here we go. And so we have a Nintendo logo. So the PI3 USB chip was dead. And now you see, oops, in the corner, we're getting a charge icon. So that means it's working. I'll still have to clean it up a little bit and test it, but test like all the other components, Joy-Cons and game cartridge reader, fan, yada yada, but 90% of the time it'll work now. So that's all, and thanks for watching.